Hi, welcome back to Mathematical Maths. So in today's video we're going to do some more examples of integration by substitution, and I'm trying just different video formats. So last time we had some people joining us, this time I'm just going to work through it by myself, and just leave in the comments which one you prefer. Anyway, we're going to get started with the integral of the ln of 3 to the power of x ln of 3 multiplied by the sine 3 to the x, okay, dx. So what we're going to do is we're going to first find our u substitute. So we're going to pick something with an x value. So in this case we consider the ln of 3 to be a coefficient, so we don't really need to worry about that or substitute anything in for that. Whereas the 3 to the power of x, we can make that u, okay? So if we take the derivative of this, that's going to be the ln of 3 multiplied by 3 to the power of x. So that's going to be du dx. So if we rearrange this, we're going to say that dx equals du divided by that, and then that's just u equals 3x. Okay? So if we start subbing in some of the stuff, we can say it's now the integral of u multiplied by the ln of 3 multiplied by sine of u dx. Now we just replace the dx with this, so then we have du divided by ln of 3 multiplied by x to the power of 3. So we know x to the power of 3 is also u. So we can change this, for example, into u, then we can cross those out. The ln's of 3, those can also cross out. So now we're just left with integral of sine u du. So when we're taking the integral of sine, what we're going to do is we're going to take the integral of the outside, then divide by the differential of the inside. But because we're differentiating with respect to du, it's just going to be 1 here. So we don't sub in any of the x's until we're absolutely finished. So now what's going to happen is we're going to get negative cosine of u, and then divided by 1, so that's just negative cosine, plus c, and then that we can just sub back in 3 to the power of x, and that's our first answer. Right, so now we will get the next question. Okay. So the next question we're going to be answering is 2x root x minus 1 dx. So yet again, we need to find what we're going to use as our u. So in this case, we'll make the x minus 1 our u. So we'll go u equals x minus 1. So we can replace this here. We can also say that x equals u minus 1. So we can put in a u here, so that's going to be 2 multiplied by u minus 1. So that just goes to 2u minus 2 multiplied by, that's going to be plus 1, sorry. Yes, we have this, and let me just bring it around, yeah. So then we're going to have it multiplied by u to the power of 1/2. So now what we can do is we can multiply this in, so they have the same terms. So we're going to say 2 multiplied by u, and then it's 1 plus 1/2, which turns to 3 over 2, plus 2, and then u 1/2. So it's just the integral of this. And what we can do here is anytime there's addition signs, you can always split it up into 2 integrals like this. 2u 3 over 2 plus the integral 2u 1/2. And if that helps, dx du. So if that helps, you can always write it out like that. So we still have these in terms of dx, so we just need to rearrange it and have it in terms of du. So if we take the derivative here, it's going to be du divided by dx. We're going to be left with 1. So all we have to do is say that x equals du, or du equals dx, because if we bring that up. So now we just need to integrate this part. So we add 1, that's 5 over 2, then we divide by 5 over 2, so it's 2 divided by 5 over 2, and then u to the 5 over 2, and that just simplifies to 5 over 4. Then for this one here, exact same thing, we're going to add 1, so u to the 3 over 2, divide by 3 over 2, so that's 2, bring the 3 to the top, the 2's cancel out, and yeah, that's our final answer. And then plus c. Okay? So I'll just explain one more time what we did here, because this one may be a bit hard to look at, because we're like, you might not be sure, why did you pick that as your C? To be honest, when you pick your U, it's often something that's in a really awkward position. Like for example, in a square root, or if you have like x plus 1 to the power of 5, you'd make that your U. It's things with the highest power, or like in a weird situation. But the more and more you do it, the better and more like you'll be being able to identify the U's. Anyway, so what happens here? We set x equal to we make u equal to x minus 1, which is this term here. Then what happens is we just rearrange this and say x equals u plus 1. And that means we can get rid of this x here. So we expanded that and got 2u plus 2 multiplied by the square root of u. From here, we just multiplied in and we got 1/2 plus 1 and then 1/2 plus 0. So we got this here. And then we still had it in terms of dx here. So we had to make it in terms of du because we're integrating with respect to u in this case. So when we took the derivative of this, we were left with 1. And then we just rearranged that, and du equals dx in this case. So we can just replace the dx with the du. So then we just had du here, and then what happened was we just integrated it and we got to this stage here. Okay? So now we'll do the next problem. Okay, we have 3 divided by 2 root x e to the root x to the third, and then dx. So let's start rewriting some of this stuff. So we can rewrite the root x to x to the power of 1/2. We can rewrite this as e to the power of 3 divided by 2. X to the power of 3 divided by 2. So in this case, because you may be thinking, well, what do I do here? Because I have a root here, but I also have something to the power of the exponent. In this case, you're going to go for the exponent, okay? So we're going to say u equals x to the 3 over 2. Okay, because in this case, when we differentiate it, this will stay the same, and everything goes around this point because this will be brought down and different things like that. So we're going to have this term here. When we differentiate it, we're going to have du dx, and that's going to be 3 divided by 2, that's going to be x to the power of 1/2. Okay, so if we rearrange this, we can have du multiplied by 2 divided by 3 and then x to the power of 1/2 equals dx. And then we also need to substitute something in for x here. So we can say this is the same as doing u to the power of 2 divided by 3 equals x. So now we're just going to substitute this in here. We're going to say the root of the integral of 3 over 2, then we're going to have 1/2 and then x to the power of 3 over 2. And because of the indices laws, we know we can multiply that in. So that's going to end up being x to the power of 3 over 4. U to the power of 3 over 4. And then we're going to have e to the u, and then we just need to plug in the dx. So from here, we're just going to plug this in. We're going to get 2 du divided, we can bring this 2 to the bottom, that'd be a bit easier, divided by 3 and x to the 1/2. So in this case, we could have actually left the x to the 1/2 here. So first of all, we'll cancel these out, we'll cancel the 2's out, And then we had u to the power 3 over 4, but in this case that's the same as x to the power 1/2. So we can actually just cancel those out because they're the same. Then we just have the integral of EU with respect to du. Anytime we integrate something like that, it's just going to be e to the u, because that all stays the same, divided by the differential of u, which is just 1. So we're left with EU, and that equals e to the power of x to the 3 over 2 plus c. Yes, okay. So in a case like this where you've replaced one of the terms, it's always good to do that, but always be sure you know what some of the prior terms are. Anyway, here's the board, and thank you for watching, and definitely subscribe, like, comment, and all those things. Thank you for watching, and stay mathematical.